Okay, so we're going to solve this system of equations. Okay, some of you won't even bother with geometrically what these are, but I want to talk briefly about them. Okay, this is an ellipse. Okay, if it said x squared plus y squared equals 25, then it would be a circle. But because there's a different coefficient in front of the x than there is the y squared, I know it's an ellipse. Okay, it would look more like an ellipse if I divide everything by 25. So then you'd have essentially x squared, we'd have 4x squared over 25 plus y squared over 25 equals 1. Okay, so you definitely can tell it's an ellipse because there's values that are under the x squared and the y squared. You also can tell that initially though because the coefficient in front of the x squared is different than the coefficient in front of the y squared.
So that's how you tell it's an ellipse?
That's how you can tell it's an ellipse just by looking at the function. Or I shouldn't say function, but at the equation, because it's not a function, it's an ellipse. Wouldn't pass the vertical line test. Okay? So I know I got an ellipse here, and this would be a line. Okay? So if you think about that geometrically, you could have no solutions if they don't hit. You could potentially have one solution if the line is tangent to the ellipse, or you could have two solutions, right? So I kind of already in my head know, okay, I'm going to have 0 solutions, I'm going to have one solution. Highly unlikely I have one, but I could have one. Okay? More than likely, he's probably going to put a problem on there where it hits twice and I need to find both solutions. That would be how I would approach this problem, thinking there's probably going to be 2 solutions. Okay? So geometrically, that thought goes through my head first. You don't have to think geometrically if you don't want to. If you don't want to think, oh, what shape is this, what shape is this, okay? You can still get all your answers algebraically without even having to process it. Okay? Any questions on that? Okay. To me, what I would do is I would solve this one for y, get y by itself. I would not get x by itself because I know I'm going to have fractions then, because I have to divide everything by 2. I would get y by itself, and whatever y is equal, I would substitute it in right for that y and then go about solving. You guys with me?
Mm-hmm.
So y would equal -1 minus 2x, right?
Yeah.
So then I'm going to take -1 minus 2x and substitute it in for this y right here. So I would write 4x squared plus. Now, when I substitute in for a variable, I always use parentheses. So this would be my setup right there. 4x squared plus, in place of the y, I'm writing -1 minus 2x, and then that quantity is going to be squared, which will require you to distribute.
You can write -2x minus 1, right?
Or -2x minus 1, yep, it will not matter.
Okay.
As long as your signs are correct, the order is fine. So far, so good?
Yep.
Okay? So, I'm going to distribute this. -1 times -1 would be 1. -1 times -2x would be positive 2x. -2x times -1 would be positive 2x. And -2x times -2x would be positive 4x squared. Okay? I did a mental FOIL, or distributing, there. Does anybody need to see that written out with the arrows and stuff? Everybody's okay on that? I'll write it out. It's not a big deal at all. We're good? Okay, now what do you think? Combine like terms, and can you tell what type of equation we're going to have? Quadratic. So do you care if I go ahead and set it equal to 0 as well then? Okay, so I'm going to have 8x squared, clearly. 4x, and then minus 24. Good? Okay. If you love the quadratic formula, go ahead and start substituting it in. I'm going to try and avoid it. Okay? But if you like the quadratic and that's what you do, go ahead and start. I'm going to try and factor it. My first step in trying to factor it would actually be do what to everything?
Divide by 8? No.
By
2.
I'd probably go 4.
4?
Because everything is
forgot that
divisible by 4. I could divide by 8, but then I'd have to be factoring with fractions. And I don't know how much you'd like that.
Yeah.
You with me?
Yeah.
You could probably do it. In fact, you might be, we'll look at both here a little bit. I would divide by 4 personally, okay? So that's going to give me 2x squared plus x minus 6 equals 0, okay? You guys might like doing the 8. X squared plus 1/2 x minus 3. The advantage to doing this is now it doesn't take that special factoring trick because you got a coefficient, or your coefficient in front of your x squared term is just 1. The tough part about this is you got to figure out what multiplies to -3 and adds to 1/2. That's the tough part about it. Okay? I'm struggling a little bit right now. Probably going to involve a 1.5 and a 2.
That's what I was kind of thinking.
So you might be able to get that. Okay? I would have just done this. I think I can help you finish that over now too. You can use that special factoring trick, but actually it's not overly difficult here. Because this is 2x squared, I know that one of these has to be a 2x and the other one has to be an x, right?
Yeah.
That's the only way two things multiply to 2x squared. If one's 2x and one's an x. 2x times x would give me. So I know this is for sure right. And then now I just kind of do a little bit of guessing and checking because I don't want to do the special factoring trick. I think it takes too long. Okay? I know I got to get a positive. So I go -3 and +2. That'd be a -6x plus 2x. Nope, let's switch them around. -4x plus 3x. That's a -1x. I want a +1x. I think that should be it. 2x squared plus 4x minus 3x minus 6. That works. Or to come back here, what multiplies to 3 and adds to 1.5? I think we said a 2 and a 1.5, right? So a +2 and a -1.5. Okay? Now what do you do with each factor? Set them equal to 0 and solve. When I set this equal to 0 and solve, I would get 3/2, or 1.5. When I set this equal to 0, I would get -2. Stop me if you have questions. 1.5, 1.5, however you guys like. Okay, so 1.5, -2. So I know now there must be two coordinates where this line meets this ellipse. Okay? I now know the x values of each one of the coordinates. So what do I do with these x values to figure out the exact coordinate where the ellipse and the lines meet? Plug these x values in. Where would you go? Ellipse or line?
Line.
I'd probably go line. Yeah, it seems a lot easier to go line. Okay? So if I plug 3/2 in for x, so -1 equals 2 times 3/2 plus y, or I guess, what am I doing? Why didn't I just do right here? That was stupid of me.
That's what I just started to do. Same thing as you did.
So y equals -1 minus 2 times 3/2. So -1 minus 3, I get -4. You guys get the same?
I'm trusting your judgment.
I just
You're just trusting me?
Yeah.
Alright, well then I'm going to double check. Yes. Yeah. So one of my answers then is 3/2, comma, -4. Right? Now, I'm going to do that again with my other x value that I got down here. So y equals -1 minus 2, and I'm going to plug in the other x value. So -1 minus negative 4, which is really plus 4, so I get 3.
Yeah.
So negative 2 comma 3. There are my two coordinates where the line and the ellipse meet.
So that's our answer?
Those are your solutions. When I say solve a system of equations, I'm looking for values, x and y values, that satisfy both equations, which is essentially geometrically saying where those two graphs meet.
Okay.
That's what solving systems will be about. You don't need to think about it geometrically, but I think certainly it can be advantageous to do that because it might tell you how many solutions there are. Okay? But really all you're going to do is solve by substitution on any ones that I would give you. Questions?
Yeah, I did the quadratic formula, and are all the answers going to come out like as nice as that one did?
I will make sure that they're factorable, to be honest. Which means yes to your question. Because I don't want to deal with you having to substitute in negative 2 plus root 7 over 9, plug that back in somewhere to find the y value that goes with it, or to find the x value that goes with it. So they will all be factorable. So, but some people don't like factoring, so you're welcome to use the quadratic formula on all of them. Lainey.
Okay, so like some of these are like doing it with hyperbolas.
Yep.
Are you gonna make it that hard?
Those actually might be even easier.
But you have a denominator thing.
Well, we can do one of those here in a moment as well. Let me finish the rest of the questions and then, yes?
How will we know if it's like no solutions or if a solution doesn't work?
Basically, you would get to this, maybe you would get to this point. It's not factorable. And if you tried using the quadratic formula, you'd get an I, which is not real.
Yeah.
So that means there are no real solutions.
Okay.
I didn't.
Most of the time, I just mess it
Okay?
up. Okay.
Alright, so let's maybe look at one of the hyperbola ones. You want to rattle one of those off for me?
Yeah. Okay. Actually, I don't know. These last two just look difficult.
Alright, let's look at them then.
Okay. X minus y equals 0. And then the other one is x minus 1 squared over 9 minus y squared equals 1.
Okay, yep.
I
Alright, so what do we got?
hyperbola.
Hyperbola,
No.
line.
Yeah.
Okay? Hyperbola, and line. Okay? We could draw this,
I don't want to draw
then let's not.
that. Okay.
Let's just solve by substitution.
Okay.
What do you want to do?
Well,
Add the y,
yeah.
so then x equals y, right? Since x equals y, plug in either the y in place of this x, or plug in the x in place of this y, and solve. Okay? Which one do you want to do, Lainey?
We'll plug in the x.
The x in place of the y? Okay.
Is that easier? I don't.
6 of one, half dozen the other. It really will not matter.
That's what I was thinking, lady.
Whatever one of these.
And then
Okay? Go ahead and do that. At this point, what would you do? And I'll tell you what I would do after that.
At this point, I would.
Multiply by 9?
That's what I would do.
Yeah.
I'd multiply everything by 9. Because
Yeah.
then I don't have to even see a fraction there anymore.
Okay. Yeah.
Because if I take this times 9, you get this. That's just 9x squared, and that's 9. And voila, no fractions. Could you have distributed this out first?
Yes.
Yep. And then multiplied everything by 9? Yep. Perfectly fine. I just want to get rid of the fraction part as soon as I can because I don't like seeing them. Okay?
Okay.
Just-
I can do it from here. I just didn't know to do the
Sure.
fraction, if I'm being honest.
So x squared minus 2x plus 1 minus 9x squared equals 9. Negative 8x squared.
Where did you get 9? Negative 2x plus 1.
What? Where, Faith?
Oh, wait, never mind. I wrote it wrong.
Okay.
Minus 8
going to divide everything by -2, so I can work with positives. I divided everything by -2, except I didn't do it correctly. And then I would factor that.
So are both sides gonna have to be a 2x then?
See, this one is where I would even debate now using the trick, because it could be a 2x and a 2x, or it could be a 4x and a 1x.
1x, yeah.
So once there starts to be more possibilities, guessing and checking sometimes can take a lot of extra time. So I might actually jump to the factoring trick at this point.
I don't know how to do that.
What's the
so-
factoring trick again?
Yeah, I don't know.
You take A times C, should be 16.
How come you didn't do that last time?
Because he doesn't
What?
like it.
It takes too long, and there weren't very many options last time. Like this time, I don't know. Is this going to be a 2x and a 2x, or is it going to be a 4x and a 1x?
Okay, yeah.
Last time, all I had was a 2x squared.
Yeah.
It's going to be a 2x and an x, guaranteed.
Never mind, definitely not doing that.
Okay? So I don't want to mess with all those combinations. And let's actually see once. Again, I'm a little concerned right now that this isn't going to be factorable. So I take A times C,
There's a
16.
quadratic formula.
1 and 16, 2 and 8, 4 and 4. None of them add to 1. Okay? So this one's not factorable. You'd have to use the quadratic. This is not going to happen on the test. The one on the test will be factorable. Okay?
Okay. No, never mind. I can do 5. Just looking at it scared me, but I can do it.
What could I do to change this
Divide by
one?
Yeah, divide by y.
If this would have been a,
Divide that.
No, I don't think so. Would you? I don't think so.
Is it a no solution or is it just like not factorable?
it's just not factorable. So
So just quadratic formulas with.
actually, it might be a no solution one.
Why would you do this?
I think I had a negative under the.
I picked problems randomly out of the book and put them onto this for you. I didn't check to see what the answers were ahead of time. That's my fault. I trusted the book wouldn't be silly with it. -1 plus or minus the square root of b squared minus 4 times a times, oh yeah, guaranteed, no solutions.
Yeah, Julia
Yeah, I was
already did
like,
it.
I got the negative, and I
You got
was
a
like,
negative
I'm
under square
not
root,
doing
that's
that.
imaginary, therefore no real solutions.
Alright.
I'm upset.
I
Okay.
liked it 'cause then I don't have to
But you get the process, right?
Yeah.
And
But you
that's-
won't put a no solution.
And you're going to
in.
get one that has solutions,
Okay.
it will be factorable,
Okay.
you will not have to use the quadratic formula.
Okay.
I do the key before I give them to you, so I know,
Okay.
alright? But I just tried to come up with this super fast before we did this.
You never gave the definition for this, or
We,
For hyperbola or for?
for solid systems.
We don't have a definition for that.
Oh, well then that's probably why. Never mind.